Just an example involving the limit definition of a derivative for the fractional exponent function 2x to the 2/3 power. So if we're using the rule, the limit definition, there's a couple of variations, but we'll go with the typical one. Limit as h approaches 0, poor quality sideways arrow, hold on. Not much better, but we'll go with it. F of x plus h minus f of x all over h. We have the f of x, we would need an f of x plus h, which is what we would get if we take the original function and replace the x value with an x plus h. Okay. So we're looking at limit as h approaches 0 of 2 parentheses x plus h to the 2/3 power minus 2x to the 2/3 all over h. Alright, so what we need to do here is come up with a way to simplify this so that that h in the denominator goes away. Now, first thing I notice is that we do have a coefficient of 2. That can be factored out, that constant multiplier right from the beginning. So I could take that out of the entire limit because it's irrelevant to the limit. It's a common factor that does not involve an h. So that's going to help a little. But I also need a relationship that's going to allow me to simplify. Right? So for that, we go back to the sum and difference of 2 cubes. In this case, difference. So difference of 2 cubes, again, the rule is a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So I want to fit this rule to the situation. All right. Now this is a cube root, not a power of 3. So if we assume that this expression here is going to take on the role of a minus b, all right, so we're basically saying let a be equal to x plus h to the 2/3, let b be equal to x to the 2/3. Using that information, we can come up with everything else. So we would just square the a value. So if we square this, all you would be doing is multiplying the exponent by 2. So x plus h to the 4/3 plus, and we need this term, which is just the product of these two. So that would be, I'll write it as x squared, x to the 2/3 first, and then x plus h to the 2/3. I'm going to move this closed paren over. And then finally, we have b squared, which is whatever this is. We're establishing that b is 2x to the 2/3, so we'll square that, which means, again, multiply the exponent by 2. So plus x to the 4/3. And what we would end up with would be what you would get if you took this and cubed it, and took this and cubed it, and then subtract the results. All right? If you're cubing an expression, you're multiplying the power by 3. So we're looking at x plus h to the second minus x to the second. All right, I'm just going to do a little shrinky dink action here. Actually, let me turn off images. little shrinky dink. There we go. So what that's giving me is the multiplier. It's telling me that if I take my numerator and multiply it by this, so if I take it and multiply the numerator by that whole trinomial, the resulting expression would be equal to the left-hand side of that expansion. All right, but we know you can't just multiply the top of a fraction by whatever the heck you want. You got to multiply the bottom by the same thing. All right. So I'll tuck that in there. So the top is going to distribute out, but the good news is we don't actually have to do the distributing, the act of distributing, because we already know what it's going to end up being. All right, it's going to end up being equivalent to this. So x plus h squared minus x squared. Then on the bottom we'd have h, and then we have all that business here. You know, we're stuck with all that. There's no way around that. Let me just clean things up a little bit. Now the numerator we could distribute out further. X plus h squared, we've done that a bunch of times by now. That's x squared plus 2xh plus h squared. We got that minus x squared up top. But everything else is going to stay put for the time being. You'll notice that the x squareds cancel and the remaining terms only consist of terms that have an h in it somewhere. Which is great news, because that was the thing I'm looking to cancel anyway. So, copy, paste. So these are gone. So we have this expression. So just continuing the journey, I suppose. I could factor out the h. So I'd be left with h, 2x, parentheses 2x plus h. The h's would cancel. So the only thing that remains on the top, or the only things, would be the 2x plus h, and now the h on the bottom, which was the troublemaker, is gone. All right, that was the thing that was causing all the problems to begin with. That was why we could not substitute indirectly, because it would have been indeterminate. All right, you plug in a 0 for h, everything would have canceled out top and bottom. 0 over 0, indeterminate, which means that there's an answer. You just got to do the algebra to get there, which is what we're doing. All right. So now I can apply my limit. Everywhere there's an h, replace it with a 0. So I have that 2 that was out in front. I'm going to have a 2x over x to the 4/3 plus x to the 2/3 x to the 2/3 plus x to the 4/3. So simplify 4x over, we have x to the 4/3. This is another x to the 4/3 when you put it together. This is a third x to the 4/3. So 3x to the 4/3. However, you could simplify even further. And just get rid of some of this stuff. Because that x is assumed to be raised to the first power. Keep the base, subtract your exponents. and you would end up with 4 over 3x to the, that 1 is really the same as saying 4 over, I'm sorry, well, I don't even know why I was about to write that. That's something. Excuse me. That 1 is the same as saying 3 over 3. So if you keep the base and subtract the exponent, subtracting toward the larger exponent, that would be 3x to the 1/3 on the bottom, or you could write with negative exponents and say 4/3 x to the negative 1/3. Either way would be fine. And if you applied the power rule to this expression to come up with the derivative using the shorthand approach, you would see that the derivative does end up equaling that value, right? Or that expression.